Kia ora, good afternoon, everybody, in my physics classes. Today is the first day of Mahuru, September. I would like to make a couple of videos today, depending upon how time goes. I'm going to break up, instead of having one big long one, I'll break it up to little bit shorter ones that you can look at one at a time and make it easier to search up what you want, which is what I mentioned here. I want to look ahead to some other videos, make some shorter videos so you can easily find the information you need without sitting through a long written on, but it should be one. My apologies for that. I'd like to introduce Georg Ohm. Georg Ohm was a German guy. Maybe he was a bit impoverished and couldn't afford a second E on his name, George. However, we'll move on. So leave that. If we have a graph, and on the graph we plot some axes, and on the bottom axis we plot the current that is needed the current that flows through a thing that carries current. And on the other axis, we plot the voltage that's needed to make it go through. Georg Ohm found that there was, for most things, not all things, but for most things, there is a nice linear relationship. And I've left off all the x's. We can put lots and lots of x's and then put a line of best fit, but this is the guts of what's going on. Now from year 11, it looks a bit like y equals mx, not even a plus c, because there is a 0 on the y-intercept. Y equals mx, but we don't have y and we don't have x. We've got v for voltage and I for current, so it looks like v is equal to m times I. Now this gradient has got meaning. It's not just a number. The gradient tells you how tough it is to get electricity through. If you've got a very flat line, a very low line close to the x-axis, you don't need many volts to push a lot of current through. If, however, you have a very, very steep line, close to that, then you need lots of volts to push a small number of amps through. And so therefore, we call that the resistance. But it's normally remembered, instead of V equals Ri, normally remembered V equals IR. It rolls off the tongue better. Now let's look at the another version of that formula. Switch it around. R is equal to V divided by I. Now that will give us a good way in to figure out the units for resistance, because the units on the left-hand side and the units on the right-hand side have to be the same. Otherwise the equation won't balance. On the right-hand side, it's volts per amp. So there has to be the units on the other side too. And so the units for resistance are volts per amp, which are named another way of looking at that is the ohm, because it's named after Georg Ohm. And because the word ohm is the first syllable in the letter omega from the Greek alphabet, we often use omega to indicate ohms. And that's kind of cool. Now in a circuit here, we've got the symbol for a resistor these days is a rectangle. And in labs it's a rectangle. Other ones you'll come across, which I'm making a thing of today because they do exist, but they're not so common. The squiggly line, because it shows you that it's hard to get electrons through there. That's the symbol. Another example here. We've got V equals IR, so I equals V divided by R. So the current will be 12 volts divided by 600 ohms. So the current will be 1/50th of an ohm, 12 divided by 600, or 600 ohms times 1/50th of an amp is going to give you 12 volts. Another version here is V equals IR. It's probably easier. V equals IR to get 5 amps flowing when you've got 200 volts needed for each amp. It's going to need 5 times 200, which is 1000 volts. And that's kind of useful. Cool. That's what I'm going to stop there today. I will possibly today, maybe tomorrow, make another video or two in which I show you how to find the total resistance when there are resistors in series and then resistors in parallel. I might make 2 separate videos for that, but I also might even sing you a little resistance song, which is kind of fun. The first ever physics song I sang. Thanks everybody. Just to close, I'm going to bring my face up here a bit bigger. I can't see you, but you can see me, and so therefore I just wish everybody well. It's tough for some families. Try and be nice. I know it's Teenagers have a default setting to be a bit grumpy and a bit tough to be around. It's just your natural setting in this world. It was mine when I was a teenager. But do what you can to be nice. Some folk are worried about money. Some folk are worried about family that they can't visit. Some people are worried about the future. So if you're nice to folk, it makes life easier for everybody to tick along. And I'd be really grateful if you would. So I'll go back down the bottom of the corner and then say cheery bye everybody, and I'll talk to you in the next video.